Now we start our final but perhaps most important mathematical topics for today, vectors. In physics, we have two types of quantity. A scalar has only a magnitude or size. Examples of scalars include temperature or speed, like 100 miles per hour. A vector has both magnitude and a direction. Velocity is a perfect example. 100 miles per hour due north. The direction is just as important as a number. We can represent vectors as arrows. They are equal if they have the same length and point in the same direction, regardless of where they start. We add them graphically by placing them tip to tail. Now pay attention, if we want to add vector A and B, we will point tail of B into tip of A, and then connect tail of A to tip of B, which give us A plus B. Now you can put tail of A to tip of B, and then connect tail of B to tip of A, which will also give us B plus A, so they are interchangeable. And by doing this, we actually can add multiple vectors together, just as we did for two vectors. We just do them one by one. To subtract a vector, we simply reverse the direction of one of the vector. So we want to do A minus B in this problem. And this is our A, this is our B. So minus B means you turn this B vector 180 degrees to the opposite direction. So now you can add A and minus B. It will give you, add A and minus B will give you A subtract B, correct? And we can multiply a vector by a scalar to make it longer, shorter, or reverse its direction. While graphic methods are good for understanding, the real power comes from breaking a vector into its components. We can think of any vector as the sum of two perpendicular vectors, one on the x-axis and one on the y-axis. We find the length of these components using the geometry we just reviewed. X component is the magnitude of the vector times the cosine of the angle. X component equals to cosine of the angle. Y component on the other side, this is Y component. This equals to Y component would be A sine theta. And tangent this angle give you Y component over X component. It's just the trigonometry. From the definition of sine and cosine, we can write the relations shown in these slides. Notice that the components form two sides of a right triangle with the hypotenuse of magnitude of this vector A. So we can write a relation using Pythagorean theorem. X component square plus Y component square, then square root give you the magnitude of this vector. Okay, try to think about this problem. We have a vector C. We have a vector C. What is the X component and the Y component of C? So I would say this is X component, this is Y component. So we need to count what's the magnitude of X component 1, 2, 3, 4. and is pointing in the negative x direction. So I would say the x component is -4, and the y component is pointing in the positive direction. The magnitude is 1, 2, right? 2 centimeter. So the y component is 2 centimeter. I would think the correct answer is D. So this gives us a better demonstration what is x component of a vector, which is magnitude times cosine theta. Y component is magnitude times sine theta. Now I would suggest you always use this, because we would call this angle of this vector theta. Now this one is a random. This one is really just a random angle. This is not. In this picture B, theta is not angle of A in this picture. So this is a recommended. This is a recommended way to remember and calculate everything. And to summarize, we can add vectors algebraically. So you can break it down vector A into x component in the x direction, y component, AY in the y direction, and vector B in the x direction and by in the y direction. So A plus B, so R of course would be Rx in the x direction, Ry in the y direction, and then Rx equals Ax plus Bx, Ry equals Ay plus By.